All right, welcome back. Let's continue. Basic electricity number 41. Equal to the voltage across the 20-watt light. Equal to the voltage across the 20-watt light. A cabin entry light of 10 watts and a dome light of 20 watts are connected in parallel to a 30-volt source. The voltage across the 10-watt light is measured will be equal to the voltage across the 20-watt light. Very simple enough. A cabin entry light of 10 watts and a dome light of 20 watts are connected in parallel to a 30-volt source. If the voltage across the 10-watt light is measured, it's gonna be equal to the voltage to the 20-watt light. All right? 20-watt light. 42. At least 35 milliwatts. At least 35 milliwatts in a 14 ohm resistor to be installed in a series circuit carrying a 0.5 amp. How much power will the resistor be required to dissipate? At least 35 milliwatts. At least 35 milliwatts. 14 ohm resistor is to be installed in a circuit, series circuit containing 0.5 amps. How much power would the resistor be required to dissipate? At least 35 milliwatts. 35 milliwatts. 35 milliwatts. Excellent. All right, so we continue. 2 volts. Okay, this will be the second question that we get with 2. Now it's telling us it's going to be 2 volts. So what is it? 002 kV equals 002 K equals. Well, it's a kilovolt. The kV stands for kilovolts. So 002 kilovolts equals 2 volts. That's it. 2 volts. Once again, number 44. We have another figure. All right, it's asking for 3 volts. 3 volts. Refer to figure 10. What is the measured voltage of the series parallel circuit between terminals A and B? A and B, it's 3 volts. The measured voltage in series parallel circuit between terminals A and B is 3 volts. 3 volts. All right, 45. It's asking for 24 ohms. That's your formula right there. Okay? Refer to figure 64. A 24-volt source is required to furnish 48 watts to a parallel circuit consisting of 2 resistors of equal value. What is the value of each resistor? 24 ohms. 24 ohms. All right? 24 ohms. A 24-volt source is required to furnish 48 watts in a parallel circuit consisting of 2 resistors of equal value. What is the value of each resistor? 24 ohms. All right, 46. A 1/5 horsepower 24-volt motor which is 75% efficient. A 1/5 horsepower 24-volt motor which is 75% efficient. Which requires the most electrical power? Which requires the most electrical power? A 1/5 horsepower 24-volt motor which is 75% efficient. 1/5 horsepower 24 motor at 75% efficient. All right. 47. Watt. What is it? A watt. What unit is used to express electrical power? Watts. What unit is used to express electrical power? A watt. What unit is used to express electrical power? A watt. Number 48. Coulomb. Remember that word. Coulomb. That's Q, right? What is the basic unit of electrical quantity? Coulomb. Coulomb. Electrical quantity. Basic unit of electrical quantity is a coulomb. It's a Q. Coulomb. Right? 49, 26 ohms. Okay, question 49, they're asking for 26 ohms. What is the operating resistance of a 30-watt light bulb designed for a 28-volt system? What is the operating resistance of a 30-watt light bulb designed for a 28-volt system? 26 ohms. 26 ohms. 26 ohms. What is the operating resistance of a 30-watt light bulb designed in a 28-volt system? 26 ohms. 50. The total current is equal to the sum of the currents through the individual branches of a circuit. The total current is equal to the sum of the currents through the individual branches of a circuit. When referencing resistance in a parallel DC circuit, which of the following statement is true? The answer is the total current is equal to the sum of the currents through the individual branches of a circuit. When referencing resistance in a parallel DC circuit, the total current is equal to the sum of the currents through the individual branches of a circuit. All right. Oh, another quiz. I'll see you in a minute.